So this is a stroboscope. In a physics laboratory, you would use this for a range of different demonstrations and experiments. Now we want to show you a way today of creating a stroboscope for next to nothing. A warning, there will be flashing images in this set of videos. You may have seen videos online of helicopters moving around in the air and the rotor blades looking apparently stationary. And this is because the frame rate of the camera matches the rotation rate of the helicopter's rotor blades. Now a stroboscope like this, if set to the right frequency, can be matched to anything that is moving. Now if I turn this on, this is a little aeroplane, you can see that it's a blur. What the stroboscope can do is it can freeze the motion like this. Okay? So these stroboscopes are really good, but this one costs about £280. Our senior physics technician Dave Ferguson has been working on a way of getting exactly the same as this for pennies. So what have you got then, Dave?
Well, this is an LED strip that you can buy from Amazon, or this one was from Rapid, so it's a little bit more expensive. And it consists of a series of LEDs which can be cut to make a display. It's quite often used in houses as backlit behind TVs and so on. Right, this is the microbit which I've programmed. There'll be a screenshot, I'm sure. But here I've got a transistor just because the power from the microbit itself is very limited. It consists of a transistor, a resistor on the signal, in this case it's 10K, that's an NPN transistor, so I've got the blue signal, blue line is the signal coming out from pin 0. This is going to our positive supply, which could be 6 volts or 12 volts, and a common earth on the 0. Right, so pressing this, and you'll notice it's setting off at 25 Hertz. I then connect this to drive the 12 volts, and we've got a signal at 25 Hertz. And if I press this button, which is button A, it should go down one at a time. It does take time for the display to pass the screen before it will change, so it's not absolutely instantaneous. So I've got this matched to now give virtually a stationary wave. If I press this display just to go up, you can see it going out of phase, but it gives us a chance to look at the display on here, so we know that it is, in this case, at 17 Hertz.
So how does it work?
Well, this is the LED strip here, which is controlled by the microbit. The microbit sends a pulse through this resistor here, which is a 10K resistor, and that triggers the transistor to allow current to flow from the 12 volts to the ground that's common to both of them. Right, what I've done is I'm using the music mode to generate a frequency. This I was displaying using the show string convert to text, and these two basically allow you to cycle through the frequencies up to 50 Hertz or down from 50 Hertz. So when it gets to 50 Hertz it goes to 0, and similarly if it gets to 0 it goes up to 50.
So £280 for an off-the-shelf stroboscope. Dave, how much is this one?
About £14 if you haven't got a microbit, but if you have got a microbit, less than 60p, and if you've got bits already in their place like transistors and resistors, next to nothing.
Excellent.